Hello, myself Parth Namdar and my teammates are Vandan Chaudhary, Shrikant Gaipad and Rahul Chandase. We are working on a project of designing and simulation of a symmetric supercapacitor by using biomass material. We have selected the two materials for the simulation, that is orange peel and teak wood, and we have found the specific capacitance and charging and discharging graph of both the materials by simulation method. We have using two simulation methods, that is hardware method and software method. We have found the super specific capacitance charging discharging graph by both the methods. We have found the specific capacitance by hardware method, by software method. Why we selected the biomass materials? Because the biomass material are cost-free materials, are available everywhere in the country and are available at the maximum quantity of the we want. So we have selected the biomass materials and we have found the specific capacitance of the material. So hence our project is designing and simulation of a supercapacitor by using biomass materials of orange peels and teak wood. Thank you.
I am Vandan Chaudhary and majorly I am involved in simulation of supercapacitor on software. Now I will explain you how the simulation is done on the software. The selection of software was initially a time-consuming process because of trial and error method. Finally, found the software named Console Multiphysics, which had all the required physics interfaces. The first step in the process of simulation was making a 3D geometry of a supercapacitor, which consisted of negative electrode separator and positive electrode. This is a 3D structure, that's 3D geometry of supercapacitor. Then material for every part was selected. It was selected from the material section. The polyethylene was inbuilt material, but the orange peel, that is the electrode material, was not inbuilt. So we created it by using a blank material. Then the physics interface was selected. There were two physics interfaces which we required, that is electrostatics and electrical circuits. The electrostatic was used to find the capacitance and specific capacitance of capacitor.
In the hardware process. For the hardware process, we have selected the two biomass materials as teak wood and orange peel. After selecting the materials, we have made the activated carbon from these materials in the Army Institute of Technology. Next, for the actual hardware making process, we have required the mesh sheet, activated carbon, MnO2 and polyethylene as a separator. For the making of anode and cathode electrodes, we have pasted the activated carbon and MnO2 in 1:1 composite ratio for the anode, while the activated carbon is totally pasted on the mesh sheet for the cathode electrode. Activated carbon, which we have made from the muffle furnace in the presence of nitrogen, is like that. And this is our supercapacitor.
Now I am going to discuss about the testing of hardware supercapacitor material. For testing, first of all we have made the connections as per the circuit diagram. Then place our supercapacitor material in the beaker, which is mixed up with the solution of distilled water and potassium sulfate with the reference voltage of 2.2 volt. We have performed the charging of that material for 3 minutes for 3 times and then for 1 minute for 5 times. Then according to the procedure, we have note down the observation and perform calculations and find out the specific capacitance of that material. And capacitance of that material we have compared with the software materials, and by comparing we have found that capacitance of teak wood material, that is 2.83 into 10 raised to minus 10 farad per gram, which is very high compared to the orange peel material. So we have concluded that teak wood material is best suitable for supercapacitor.